Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're going to come back at the end to wrap it up. In today's episode, we're going to look at transistor as a switch. Now what we have here on the screen is an LED, light emitting diode. When you connect power to it, to the positive, and you have it grounded, the LED will come on. Now this LED is connected to the positive through a resistor. The function of this resistor is to limit the current flowing through the LED. Now when you power this up this way, the LED stays on because there's no control, really, there's no switch here. To connect a switch to this, in order to turn it on and off, you will have to reconfigure this to be this way. I have my resistor here, I have my LED, then I have a switch, and then to ground. Now this switch can be the other way too, so here's my positive. I can also have it the other way around, where I have my positive, I have my switch. It can be before or after the resistor, doesn't matter. The LED and the ground. Alright, so this will be my limiting resistor, and then that way. So this switch here, we're going to use a transistor to build the switch. Alright, so first off, what you have on your screen, we have configured it on a breadboard, and you can see it here, the LED, the resistor, and the power supply. Alright, so this LED, this is a blue LED, we can also use a red LED, just flipping it around. So you can use any LED of choice, but today we're going to use the blue LED. Alright, so that is our blue LED. Now we're going to add transistor to function as a switch. To do that, we're going to use circuit B. So this transistor here, when you have a resistor from the power supply to the base, so if we just connect the resistor this way, the resistor will take some current to bias this transistor, and the transistor effectively closes this way as a switch, and then the current will complete the circuit and the LED will glow. So let's show that here. We're going to use an NPN transistor, 2N2222, and the polarities are, or the pins are, so if it's facing you, 2N2222. The pins will be emitter, base, collector. Emitter, base, collector. Alright, so let's wire that up and we'll see how it goes. So here in this circuit, the emitter goes to ground, so that will be this pin will go to ground, and then the center is the base, and then the side is the collector. The collector in this case goes to the cathode. If you can see here, here is our cathode or cathode, and there is the anode. When current flows in this direction, when conventional current flows in that direction, the LED will glow. So let's go back here and wire this up. First of all, to do anything, we have to take out the power. We don't want to blow anything in the process. So emitter goes to ground, collector goes to the cathode, and basically our base is open for now. So, and that's it. I think that's all. So one wire, the negative of the battery goes to ground or to the emitter, and then positive through the resistor, and then yeah, So we have to connect another wire from the positive and the other wire to the base. And when you now touch those two wires, the LED will come on. So our finger is actually helping us to close the circuit, and then the LED comes on. And we're going to add one more resistor, 270 ohm resistor, because this voltage, the power supply is really high, 7.4 volts. It's high, so we're going to use that as a limit. This resistor as a limiting resistor from the power supply, and then we're going to have a different resistor as the 220 ohms. So in this circuit, we'll be using 270 instead of 220 ohms. So let's make it 270 ohms. This is not critical, that's the component we have. Alright, so power it up now, and when I touch, the LED comes on. So my hand is helping to close the circuit. I can hold it, one hand on each pin. Alright, so what we're going to do here now is to introduce the second transistor circuit, or in this case that will be figure C. Here we're going to introduce another transistor connecting to this first transistor. Again, we're going to use another NPN transistor, 2N2222 in the same configuration. The emitter goes to the base, so let's remove the power. The emitter goes to the base, alright, and the collector goes through 15 kilo ohm resistor. 15 kilo ohm resistor is brown, green, orange. So that goes from the collector to the positive. And because of how this is stretched out, I have to adjust the first resistor here to adjust the location so that the other resistors can reach. Alright, so now just gonna power it on again. My ground goes to the emitter here, and then the base and the positive. Again, now you can see it's more sensitive. Even before I touch it, it cannot start flickering, and just holding one wire also causes it to glow. Right, so I need lesser current now to power it on, because the transistor is amplifying, this first transistor is amplifying the current and then using that to fire the second transistor, to bias the second transistor or the first transistor. Now I'm going to add the third transistor. That will be the last transistor in this circuit. So this transistor, again, NPN, in the same configuration, emitter, base, collector. So the emitter will go to the base, all right, emitter goes to the base, and this 15 kilo ohm resistor right here is replaced by 100 kilo ohm resistor, and the color code is brown, black, yellow. Yellow is 4, and in the third position is a decimal multiplier, so it goes from here to the positive, and then the last transistor Q1, or the last transistor now in this case, will connect through one mega ohm resistor, and the color code is brown, black, green. Green is 5. In position number 3 is a decimal multiplier, so multiplied by 10 raised to the power 5. All right, so let's get that in. I need to take out the power supply because you don't want to blow something if you shut something by mistake, if you shut the terminals by mistake. All right, so let's check this out. Now we just need one wire to the base, and as soon as you connect the wire to the base, it lights up. Now we're using just one wire. We don't even need to touch the terminal. Just touching the wire, just parts of the wire will cause it to light up. Now, so we're going to connect this wire here. We have an aluminum foil connected to one end of the wire, so it can just serve as an antenna to pick up signals around it. So as you come closer to the antenna wire, the LED comes on. This is amazing. Now think of other things you can do with this, like a proximity sensor, maybe a car alarm. When someone comes closer to your car, the alarm will go off. Right, so just trying to put this on a stand. All right, so you notice that whenever my hand is off the antenna, the light goes off almost right away. All right, what we're going to introduce now is a delay. We want to introduce a delay to this circuit, whereby when I take my hand off, the light will stay on for a little while. To do that, the reason this LED goes on is because there's current coming from the base circuit. So if we can introduce some current at this base circuit, then the LED should stay on for longer. To do that, we're going to introduce just a simple component, a storage component, a storage device. In this case, a capacitor. If we have a capacitor here, this capacitor should be able to store some charges in the form of voltage, and then this charge will be used to bias this transistor when whatever is supplying that is removed. So imagine there's voltage coming in here from a different source, V or I current, and charges this capacitor and is stored here. This capacitor stores this charge in form of voltage and discharges it through the base of this transistor. Then this LED will come on. That's what we're going to do right now. So let's simulate that. So we're going to connect this way. So here's the capacitor. This capacitor is 47 microfarads and 63 volts. 47 microfarads, 63 volts. So remember I said earlier, ensure that the voltage of your capacitor can handle the voltage of your power supply, and in this case it can. So we're gonna go from the base to the ground. All right, and as soon as we hold this, the power will not come on immediately. The LED will not light on immediately. The reason being that the capacitor is a DC open circuit. So when you connect power to it, first of all, there will be a jitter that will force it to short to ground, and then it will gradually charge up. As it charges up to about 2/3 of the power supply, that power or that voltage will now be used to bias this transistor. Now you can see, as I held it for longer, the charge built up enough to power this LED, to bias this transistor, which powers the LED. When I release this wire, I will remove the antenna entirely. The LED stays on for a while. It will go off eventually, but it stays on for a while, then gradually goes off. Now, the charge is stored in that capacitor is equal to I T, where I is current and T is time. So this is the time it takes to charge the capacitor and to discharge the capacitor. Now we know when you supply power or voltage to a capacitor, it will store a charge which varies with the supply voltage. And the proportionality constant here is the capacitance. So the capacitance of a capacitor is the constant of proportionality between the quantity of charge Q and the potential difference V. This then means that C is equal to Q over V. So this then means that T from here is equal to Q over I. And we know that Q is equal to CV, therefore T is equal to CV over I. Now from Ohm's law, we know that V is equal to IR, such that R is V over I. Now when you substitute this into this function here, we have C multiplied by V over I. Since V over I is R, then T therefore T is equal to C R or RC. So the time to charge and discharge the capacitor is equivalent to the resistance multiplied by the capacitance. Alright, so that's what we have here. We've introduced a delay that times out with time. So we're gonna try to fire on the capacitor one more time. So we're gonna go to the base, and it charges right away and it starts to discharge because we didn't hold it for long. Then it's going to discharge gradually. Now when I take off this, see, when I hold it, it goes brighter. When I release it, it starts to dim. You can see from the sideways, from sideways it's more visible. When I hold it very bright, when I release it, it starts to dim. Hold, release, and it starts to dim. Now, one thing we can do is to introduce this capacitor at different junctures. Try to move this capacitor in your build. Try to move this capacitor to different locations. So we're going to put this capacitor here. And then we're going to try to also put it here. Do this and let us know the delays that you were able to introduce. So move it that way. You can also have all three on at the same time and experiment with that. What kind of delays you would get. But I'll predict for you this last capacitor here. Let's just call it C1, C2, and C3. C1 will produce the longest delay, and then C2 less than that, and then C3 the least, if the capacitance values are the same. And if you have all three on at the same time, the delay will be incremental, because it will take a longer while for this to charge, since it's going to be charging from basically stray resistance from your fingers or the fields picked up from the atmosphere. It will take longer to charge this, then this will be charged, and then this also will be charged. So C3 will also be charged. So we're going to do C2 now, and we call it a day. So to do that, we have to first of all discharge the capacitor. So take out the capacitor and shut the pins out. That's the easiest way to discharge the capacitor. So just shut the terminal, and then we're going to connect. Let's take out the power supply now, and we're going to connect from the base of Q2 and emitter of Q1. We're going to connect right here. So let's do that. All right, so let's power it up. And as predicted, this will take some time to charge. So we're just going to hold it for a while it charges. It might look like nothing is happening initially, but I'll explain to you what is going on. So the moment you connect it, this shuts to ground, just like it happened in the first instance. And then it starts to build up the charge until it gets enough to bias this transistor. So you need about 0.7 volts charge in the capacitor to be able to bias the transistor. Just checking that we connected it properly. Yes, we did. As you can see, gradually it's coming up. So it's charged enough. So the voltage is big enough to overcome the base emitter voltage, or they call it VBE, of about 0.7 volts or above. Now the transistor is on. I can take out this wire, and it stays on and remains on for a while it discharges. According to the formula we've calculated, T is equal to RC. Alright, so once you plug in the capacitor and you hold this antenna or this wire, this base wire, it will take a while to build up some charge, and that charge on the capacitor will be used to overcome the base emitter voltage, which is about 0.7 volts for a silicon transistor, and probably around 0.3 for a germanium transistor. It looks like nothing is happening right now, but the charge is building up gradually on the capacitor. It will build up enough that it will bias the transistor. You can see now it's built up enough charge. The light is coming on gradually, and it's going to go fully bright shortly. Now, even when I remove this wire, the LED stays lit because the capacitor is already fully charged, or at least somewhat charged. It keeps the charge and keeps our transistor on. And it will take the same equivalent amount of time for charging to discharge. So the T will be equal to RC, resistance, capacitance. All right. The last thing to do now is to take this capacitor and connect it to the first transistor, and it's going to be in the same way. So we're going to take the capacitor and discharge it. We will short it out with another wire or another capacitor. Just short the two terminals to make sure we discharged it, and then we connect it again from the base of T1 or Q1 to the ground. So from base to the ground. And now, having done that, now we just need to connect the two wires from the base and the positive. So we're going to go base, positive, and we're going to hold the two wires together for a while to let the capacitor charge. So I'm going to hold it for a while, and as before, it will look as if nothing is happening, but with time the capacitor will charge up. And this time is determined by the voltage and the resistance on the path. So really it doesn't look like much is happening. So let's give it a couple of minutes, a couple of seconds, and see what happens. Now if you're in my position here, you will see it starting to glow a little bit, and it's coming. Not full yet, but it's coming. Alright, while that is happening, I will explain something to you. So when this capacitor charges, it will discharge. Let me use a different color. It will discharge through this Q1, and then through Q2 and through Q3 to the ground, and the LED will come on. So that's what is happening now. You can see it's fully lit now. Alright, so even when I remove this wire totally off the circuit, not even the antenna wire, the LED stays on for a while. This time is determined by the value of RC, as we can see right here. So you can use this project for a security system where if someone touches or approaches it to certain distance, the LED will go on if the person stayed on for a certain amount of time. If you just want to trigger it right away, then you might want to change the location of your capacitor. You might want to put it closer to Q3 than Q1. Alright, and also if you just want to trigger something right away without a delay, then you might consider not using a capacitor at all. As I stated earlier on, this transistor will stay on until the capacitor is fully discharged, or discharge below 0.6 volts. And this is really going to be a long time because of the path it's taken to discharge. It's going to go through Q1, Q2, and Q3. And the resistance of this path is really high. It will take as much as it took to charge it to lit up for it to discharge. Alright, thanks for watching, and I'll see you in the next one. In our next episode, we'll be looking at LEDs, light dependent resistors, diodes, and transistors, and using that as a switch as well. Alright, I'll see you in the next one. If you have subscribed, I want to thank you. If you haven't, you know what to do. Alright, thank you so much.
Alright, thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now, and don't forget to like and share this video. Until we come your way again with more contents, stay enthused.